Welcome back, student. This is lecture number 3 for course name Structural Dynamics. My name is Mohammed Zain, Assistant Professor, Faculty of Civil Engineering, Sri Ramsur Memorial University. Now, today we'll be covering the topic name Damped Free Vibration of Single Degree of Freedom System. Now, in today's lecture, we will be covering Introduction to Damping, we can say. Introduction to damping, then types of damping. Basically, we will be dealing with the viscous damping and equation of motion for the viscous damping. In this equation of motion, uh, we will be taking critical damping condition, under damping condition, and over damping condition when they will be arising. Okay, let's move further. Okay, now introduction. Now, as we have discussed previously, what is vibration? We have discussed it in the previous lectures. So, in that, I have just given a hint about the damping. See, anything which opposes the motion is known as damping. Okay, so here, this is damping is the phenomenon in which the energy of the system is gradually reduced or amplitude of the vibration goes on decreasing and finally the vibration of the system is completely eliminated and the system is brought to rest. Okay, see, there are this is the actual definition and you can remember, say, this is the pen here, and I'm putting a pressure here. Okay, see, it went into vibration, but it came back to its original position. Now, what happened? The intermolecule of this pen, we can say, or the joint between these two was rigid, and which was making it to come back to rest or equilibrium condition. Okay, so next. Next line is written, the rate of decreasing the amplitude depends upon the amount of damping. Okay, if the damping is more, the rate of decreasing the amplitude will be more. Okay, the advantage of this damping is to control the amplitude of vibration. Okay, now what happens, as we have discussed in the previous lecture, that vibration has a negative impact on our structure. Okay, so if this vibration amplitude is get reduced, so our structure is able to bear it. Okay, so that's why damping is a very critical phenomenon, and we can say, or a structure mainly depends upon the damping. So due to this damping only our dynamic load can be dispersed or can be controlled. Okay, let's moving on to the now there are basically five types of damping available. Okay, viscous damping, when the resistance is made due to the fluid. Okay, when the resistance to the motion is made because of the viscous medium of the fluid. And Coulomb damping, when the resistance is made due to the friction. Okay, like a body is kept over here and if you want to move it, then the frictional force is acting against it. This is a kind of friction, Coulomb damping only. Structural damping, so when the molecule of the structure mm, opposes the motion is known as structural damping. See, let it this be the beam. Okay, now you have put a load over here. Now it get deflected a bit from this position to here. Now these molecule adjacent to the load want to get back to its original position. Load is acting over here. They are resisting this load or resisting this deflection. This is the structural damping. Now active or negative damping. Active damping actually refers to the energy dissipation from the system by external means. Okay, energy dissipation from the system by some external means such as control actuators are known as, this is called as active or negative damping. Okay, now passive damping. Okay, uh, passive damping means to say in which there is an energy dissipation within the structure by some damping devices such as base isolator, base isolators, comma, tuned mass damper, TMD, I'm writing in short form, TMD. Okay, these are some types of passive damping devices. Okay, see now the equation of motion for viscous damping. Let's this be a system. Okay, and this damper is the fluid, you can say, which is offering the resistance to the motion. Okay, now here we are showing you damper. Okay, this is the stiffness offered, and this is the that mathematical model, the weight at the slab level. Okay, it has been displayed x distance here. Now what will happen, and due to the inertial force, mass into acceleration will be there, force equals to ma, inertial force. Okay, and this is due to the damping effect, and this is due to the stiffness of the spring, or this is provided by the column, and this is by the mm, by the by the dampers, and this is due to the inertial forces. Okay, let's write the equation. Okay, I have leave this slide uh, blank for writing this equation. uh, mx double dot plus kx plus cx dot single dot, it is single dot, is equals to 0. Okay, so now what is happening, let assume the solution to be in the form of x is equals to e की power lambda t. Now single differentiate, after single differentiation we are getting the velocity, this is x dot will be equals to lambda e की power lambda t, and then x double dot, that is acceleration, will be equals to lambda square e की power lambda t. Now putting all these, let us assume this to be equation 1, all these value of x dot and x double dot in equation 1, and after solving this we will be getting an equation like lambda square plus c by m lambda plus k by m is equals to 0. This is a coordinating equation, or you can say the characteristic equation. Write it here, equation number 2, and let it this be the characteristic equation. Okay. Okay, now from the above equation we know that the solution will be equals to lambda 1 comma 2, this will equal to minus c by m plus minus root over b square, that is c by m whole square, minus 4ac 4k by m divided by 2a 2. Okay, now the radical term here is this is called as the radical term, or we can say the discriminant term. So the discriminant or radical term radical term is uh, let I think we should write this on the next equation. The radical term is, okay, radical term is, okay, this will be c square divided by m square minus 4k by m. Okay, now why I've written this here, because this radical term will only decide, this term will decide whether your equation, or you can say your solution, or you can say your system is critically damped, under damped, or over damped. Okay, if the discriminant is positive, okay, if the discriminant is positive, The system is termed as overdam system. Okay, means to say if this value is greater than 0. Okay, it means that the root of the characteristic equation are purely real and distinct, corresponding to simple exponential decaying motion. Okay, now the second, if the discriminant is negative, the system is termed as under dam system. Okay, if this system is less than 0, now it means it refers the roots of the characteristic equation are complex conjugate corresponding to oscillatory motion with an exponential decay in amplitude. Okay, now if the discriminant is equal to 0, means that the value of this discriminant is equal to 0, the system is termed as critically damped system. Okay, now it means that the roots of the characteristic equation are equal corresponding to simple decaying motion. Okay, uh, actually in reality basis we want that our system to be critically damped, because it will take if we will let makes a make a figure and understand from that. Okay, um, okay, now let this be the let this with a figure. Okay, now we understand what will happen to the overdamp system. Let's first talk about the underdamp. Okay, the underdamping will be defined as the vibration. Okay, like this is a underdamping system. Okay, it will go reduce slow by slow. Okay, now what will be happen to overdamp? Huh? The overdamp will decrease slowly. And what will happen critically damp? It is the shortest time or shortest path taken by the system, or the time taken by the system to come back to rest, or and it does not undergo vibration. Okay, now the example of this underdamp you must have seen. Mhm, uh, the some of the door are there in the previous, or you can say the our brake system, hydraulic brake system, or your suspension are basically like your suspension are basically work like under dam system only. Okay, for over dam your door closers, for over dam door closers are there, which you use in day-to-day life. These are an example of over dam system. Okay, now move on. These are the three system. Okay, thank you very much for attending today's lecture. Now we will meeting lecture number 4, last lecture for this.